March 22, paper 2, variant 2. Okay. Student investigates a pendulum. He measures the time for the pendulum to complete 20 oscillations. He repeats the experiment 3 more times. The readings are shown. What is the average period of the pendulum? Can I find the average period? Yes. Can I add the numbers? 17.6 plus 19.8 plus 17.6 plus 18.6 divided by what? Divided by 4. This will give you a total time of, I guess, 18.4. Okay, let me calculate it again quickly. 17.6 plus 19.8 plus 17.6 plus 18.6 divided by 4. Yes, exactly. 18.4. So is the answer D? No, the answer is not D. Okay. 18.4. It should not. Why shouldn't it be D? Because this is the time for 20 oscillations. We need the average period. The period is the time for one oscillation. So we need to divide this by 20, giving you a period of 0.92 seconds. A tennis ball falls from the upstairs window of a house. What can be said about the acceleration of the ball if the air resistance is ignored? When you ignore the air resistance, then the acceleration is constant, right? The acceleration is constant. It depends on the density of the ball, depends on the mass of the ball. It increases as the ball falls. It stays the same. Yes, it is constant. A car joins a road at a speed of 14 meters per second, accelerates at 4 meters per second squared for 5 seconds. What is the final speed? Acceleration, v minus u over t to find the final speed, to find v. Okay, what do I have? I have all of the values, so 4 equals v minus the initial velocity, which is 14, divided by the time, which is 5 seconds. To find v, I'll say 4 times 5. 4 times 5 is equal to v minus 14, and then you just add 14. So 4 times 5 is 20 plus 14. This is 34 meters per second. The gravitational field strength is 8.8 on Venus and 3.8 on Mars. An object has a weight of 42 newtons on Venus. What is the mass and what is the weight on the moon? Can I find the mass? Mass equals weight over g. It's not 9.8, it's not 10, it should be 8.8 because we're talking about Venus. So 42, not 4.2, divided by 8.8. Okay, 42 divided by 8.8, this is a 4.8 kilograms, right? 4.8 kilograms. Now, to find the weight on the moon, weight equals mg, or basically 4.8 times the gravitation field strength. I'm sorry, this is not moon, this is Mars, times 3.8, which is 18. So it's A. A student carries out an experiment to find the density of the rock. Which two measurements does the student need to determine the density? Density equals mass over volume. So you need the change in the mass and you need the change in the volume. Increase in the mass, I need the increase in the mass and the increase in the depth of the liquid or the volume of the liquid, the volume of the liquid, right? A car has a mass of 1,500 kilograms. A constant resultant force acts on the car. It accelerates from 15 to 20 in 4 seconds. What is the resultant force? Can I find the resultant force? Yes. You can use either equations. You can say force equals mass times acceleration, or you can say Ft equals mv minus mu. Both are the same. Okay, so if you say Ft equals mv minus mu, the force times the time of 4 seconds would be equal to mv 1500 times 20 minus 1500 times 15, and then you divide 1500 times 15, and then you divide this by 4, right, giving you a force of 1900 newtons, right? Okay. A metal wire is loaded up to the limit of proportionality. Which statement is correct? Hooke's law is not obeyed when the load is increased from 0 to this point. No, it is obeyed. When the load is increased beyond the limit of proportionality, the diameter of the wire will increase. Diameter of the wire will increase. What does this have to do? No, actually, if anything, it might actually decrease. So this is wrong. When the load is removed, the wire returns to its original length. Does it return to its original length? Yes. Why? Because you have not yet exceeded the limit of proportionality. You are still obeying Hooke's law. The diagram shows a uniform meter rule. Mn is pivoted at the midpoint P. Two weights, W1 and W2, are hung on either side. Which row is correct? Direction of the resultant moment about M. Direction of the resultant force. If the ruler is balanced, then the resultant force would be what? Be zero, right? Resultant force is zero. Direction of the resultant force on the ruler is also zero, right? It's also zero. Why? Because this is in equilibrium. It's in equilibrium. Resultant force is zero and resultant moment is zero. Which physical quantity is a vector? The only vector quantity is the velocity. A resultant force of 500 newtons acts for 10 seconds on a mass of 1000 kilograms. This causes the velocity of the car to double. What is the final velocity of the car? Can I find the final velocity? Yes, I can. Force, you have the impulse. Okay, so force times time. Force times time equals mv minus mu. But you need to say something. You need to say that the final velocity is doubled. So v, okay, is actually equal to 2u. V is equal to what? To 2u. Can I remove v? Can I remove v and write 2u? Yes, I can. Right? You can remove v and write 2u. So instead of writing this, I can write down 2mu minus mu would be equal to force times time. 2mu minus mu is equal to mu. Okay, force times time. Do I have the force? Yes, 500 newtons times the time of 10 seconds. This is equal to 1000 times u, right? If you multiply 500 times 10, this is 5,000, and you divide by 1,000. So 5,000 divided by 1,000, this is what? So u is equal to 5 meters per second. This is what? This is the initial velocity. He wants to find the final velocity. What is the final velocity? It's equal to 2u. So basically 2 times 5, which is 10 meters per second. The final velocity of the car. Right? A child pushes a toy car along a horizontal surface and then releases it. As the car slows down, what is the main energy transfer? As it slows down. From chemical? No. From kinetic, yes, to thermal, right? Because it slows down due to the friction. At time 0, cannonball is stationed inside a cannon. The cannonball is then fired from the cannon. At time t, the cannonball moves forward and the cannon moves backward. What happens to total kinetic energy, the total momentum of the cannon and the cannonball between 0 and t? Total kinetic energy, does it increase? Or does it change? Yes, it does change. Why? Because they both move. They both move. The cannonball moves forward and the cannon moves backwards, so they both move, resulting in a change of the kinetic energy, the total kinetic energy of this system. Now, what about the total momentum of the objects? What about the total momentum of the system? Does it change? No, it does not change. How so? You have one object moving forward and one object moving backwards. So you have a positive momentum and a negative momentum. The initial momentum was zero, and the final momentum will also be zero. Why? Because the positive momentum cancels out the negative momentum, resulting in a zero momentum as well. So the momentum does not change, but the kinetic energy changes. In a small hydroelectric power scheme, 800 kilograms of water drops through a vertical height of 2.2 meters every second, right? The electrical output is 10.6 kilowatts. What is the efficiency of the scheme? Okay, so now you have 10.6 kilowatt, which is the output. Can I find the total input? 800 kilograms, height 2.2 every second. So to find the power, this would be the energy over the time taken. The energy would be the gravitational potential energy, mgh, 800 times 9.8 or times 10 times 2.2 divided by the time, which is every second. What is this value? 800 times 10 times 2.2. This is 17,600 watts, right? So the power is now equal to 17,600 watts. This is the total input. The total output is 10,600. Can I find the efficiency? Yes, the efficiency would be equal to 10,600 divided by 17,600. 10,600 divided by 17,600, which is 0.60 or 60%. It is 60% efficient. An object is at rest on a horizontal surface. On a horizontal surface. Which equation is used to calculate the pressure that the object exerts? Force over area, right? Weight over area. Smoke particles illuminated by a bright lamp are seen. They move about randomly. What causes this motion? What causes this motion? Collisions, right? Only collisions. Question 16. Ether is a liquid that evaporates easily at room temperature. At the rate at which the ether evaporates can be increased by bubbling air through it. The diagram shows this process. Students give 3 suggestions why the rate of evaporation increases when air is bubbled through. Student 1, okay, student 1 says that the temperature of the ether is decreased. Okay, does this increase? Okay, the rate of ether evaporates can be increased by bubbling air through it. So would decreasing the temperature increase the rate? No, it wouldn't increase the rate. Okay, it would not increase the rate. Student 2 suggests that the surface area of the ether is increased. Yes, when you increase the surface area, this would increase the rate of evaporation. Student 3 suggests that the evaporated molecules are removed at a greater rate. Evaporated molecules are removed at a greater rate. For example, if there's some wind or something, yes, it would increase the rate of evaporation. So this is also correct. So only 2 and 3. Only 2 and 3. Some ice is slowly heated and its temperature is measured. Which row describes what happens to the thermal energy and the temperature in X? Section X. What happens to the thermal energy? The ice, it gains thermal energy, right? It does gain thermal energy. What about the temperature? Melting ice, it is the same, of 0 degrees. So it's B. Okay, now we have a thermometer. We want to find the specific heat capacity of the material shown, right? Which piece of apparatus could be omitted if the purpose of the experiment is to determine the thermal capacity? So this question is actually cancelled. Why? Because the thermal capacity itself has been removed. Okay, I know initially he was talking about the specific heat capacity, but he wants to find the thermal capacity. It has been removed, so this question is cancelled. Which row gives the correct difference between boiling and evaporation? Boiling and evaporation. Boiling, no bubbles occurs at all temperatures, occurs throughout the liquid. Occurs throughout the liquid, doesn't it? Yes. Evaporation occurs only at the surface. Yes. So this is the correct answer. Which statement describes the thermal conduction in metals by electrons? Electrons freely move in the metal, right? Free moving electrons. These are all wrong answers. A tank contains water. Ripples are produced on the surface of the water. Refraction is observed. What causes the ripples to refract? Refraction is when you have a change in the, when we're talking about water waves, it's when you have a change in the depth, right? When it moves from deep to shallow, the speed increases or decreases or whatever. The cold water is replaced by, no, the ripples change speed as they move. Yes, they do change the speed. So this is the cause of the refraction. The diagram shows wavefronts of a water wave passing through a gap in a barrier. Which change will increase the diffraction of the wave as it passes through the gap? You want to increase the diffraction. You want to increase the diffraction. What should you do to the width of the gap. For example, you should decrease the width of the gap. What should you do to the wavelength? You should increase the wavelength. So you have neither answer, right? Increase the amplitude does nothing. Increase the width of the gap. No, I actually want to decrease the width of the gap. Reduce the depth of the water. It will not change anything. Reduce the or actually, if you reduce the depth of water, you'd have a shallow water and therefore a smaller wavelength, which is wrong. Reduce the frequency. Does the frequency affect anything? Yes, it does. When you reduce the frequency, what happens to the wavelength? The wavelength increases, and therefore the diffraction increases as well. So it's D. Diagrams each show a ray of light of an object O passing through the thin converging lens. The principal focuses in each diagram are labeled F. Which diagrams are correct? Which diagrams are correct? So in diagram 1, object line is passing right through the center. Is this correct? Yes, you have one of the rays passing through the center, which is 100% correct. In 2, it was moving parallel, okay, and then it was refracted through some random point. Does it refract through some random point, or should it refract exactly through the focal point? Yes, it should. That's why this is wrong. 2 is wrong. What about 3? As it passes through the focal point, it moves in a parallel way. Yes, this is correct. So 1 and 3 are correct. Okay. The diagram shows a ray of light inside an optical fiber. The light is totally reflected within the fiber. The refractive index is 1.39. Which condition ensures the total internal reflection occurs? The refractive index is what? Is 1.39. What can I find using the refractive index? I can find the critical angle, because n equals 1 over sine c. To find c, it would be sine inverse 1 over n, or 1 over 1.39, right? 1 over 1.39. So it's 47. Okay, C is around 47 degrees. For total internal reflection to happen, the angle of incidence has to be greater than 47 degrees. Where is the angle of incidence? Where is that? It's Q, right? It is Q. So Q needs to be greater than 47 degrees. This is the total internal reflection. Okay? An eclipse from the sun happens when the moon comes between the earth and the sun. Which statement is correct? Which statement is correct? Infrared radiation disappears before visible light and ultraviolet. Ultraviolet disappears before, visible light disappears before. Infrared, ultraviolet, and visible light all disappear at the same time. Don't they all move at the same speed? Yes, they do. So they will all disappear at the same time. Okay. Which row identifies the position of a compression and a rarefaction? The compression at X, okay, this seems to be a compression. A rarefaction at Y, yes, this seems to be a rarefaction. This is correct. A is the correct answer. Which diagram shows the charge distribution on the spheres? If they are both, okay, which diagram shows the charge? So you have negative, negative, and negative. Should they repel or should they attract? They definitely should repel. So it would be D. Negative electrons are moving away from each other as much as possible. Two separate circuits have different power supplies. Both power supplies provide the same magnitude of current. Same magnitude of current. Power supply P has an electromotive force of 1.5. Q has an electromotive force of 3 volts. Which statements about Q are correct when compared with P? Which statements about Q are correct when compared? Q supplies twice the charge per unit time. Charge per unit time, isn't that the current? I equals Q over T. Q, twice the current. Aren't they the same current? The same current. Yes, they are. So one is wrong. Q supplies twice the energy per unit time, twice the power. Does it supply twice the power? Yes, it does supply twice the power. P equals IV, right? P equals IV. So you have the same current but twice the voltage. So yes, this is twice the energy per unit. I'm sorry, twice the energy per unit time. That's what I did. Does it supply twice the energy per unit charge? Yes, it does. What is energy per unit charge? This is the voltage. Energy per unit charge. So again, both are correct. 2 and 3 are both correct. Okay. Question 29. Diagram shows a piece of metal resistance wire. Which wire made of the same metal has a smaller resistance? Smaller resistance. What should I do to the length and what should I do to the area? I need to decrease the length and increase the area. So it's either the same length or a greater length. No, I would stick with the same length. What about the diameter? I need to increase the diameter to decrease the resistance. Which label component controls the brightness of lamp X? Lamp X is controlled by a variable resistor. A circuit includes a battery, two identical resistors, and 5 ammeters PQ, R, S, and T. Which statement about the readings on the ammeters is not correct? Which statement is wrong? P has a greater reading than Q. P and Q, they should be equal, shouldn't they? Yes, they should, because they are right next to the battery, like right next to the power source, so they both have the same value, and actually they have the greatest value in the whole circuit. Okay, an electrician sets up a potential divider circuits in a fridge so that when the fridge door is open and the light from the room enters the fridge, a warning light turns on. Which component does he need? Which component does he need? Depends on the light, so it's a light dependent resistor. 33 is cancelled. 34 is also cancelled. 35. Two magnets are placed near a current carrying coil. Diagram shows this experimental arrangement. Which statement is correct? Which statement is correct? So both X and Y are attracted, they are both repelled. One is attracted and the other is repelled. How should I know? Using the right hand rule grip. Using what? The right hand rule grip. So you'd find that if you use the right hand rule grip, the north pole of this solenoid would be on the right hand side and the south pole would be on the left hand side. So this would repel and this would also repel. X and Y are both repelled. Again, using the right hand rule grip. You have two circuits which are shown. What happens to the size of the gap X when switch S is closed? Again, you can think about it using the not Fleming's, using the right hand rule grip, okay? Or you can just take a look at the battery. Okay, take a look at both batteries. Aren't both batteries reversed? Yes, they are both reversed, indicating that they will produce opposite magnetic poles, right? In the solenoid due to the current and whatnot. So they will both produce opposite magnetic fields. If you have opposite magnetic fields, this means, okay, let's see. Hmm. When S is closed, yes, what happens to this size? The size would actually, yes, it should increase. Yes, definitely, it should increase, right? When a current carrying conductor is placed in a magnetic field, it experiences a force. It experiences a force. Which statement about this force is correct? It is parallel. Is it parallel? It's not parallel to the magnetic field. It is not parallel to the magnetic field. It is perpendicular to the magnetic field and no, it is perpendicular to both yes. Using okay Fleming's left hand rule, you'd find that all of these three um, okay the magnetic field, the force, and the current are all perpendicular to each other. Question 38. Which row describes a conclusion that can be drawn from each of these observations? Most follow path X. Some follow path Y. If most of the alpha particles follow path X, this means what? This means that most of the atom is empty, right? Most of the atom is empty. Some of them follow path Y. Why? Because the atom contains something that repels alpha particles. Yes, but B is correct. The nucleus contains protons and neutrons. This is correct, isn't it? It is correct, but it's not what we found, or it's not what Rutherford found or concluded when he conducted this experiment. We found this out later on, after he conducted this experiment, maybe decades after he conducted this experiment. Okay, but when he conducted this experiment, he concluded that the atom contains something. He did not know yet what this something was. Okay, but he concluded that there was something that could repel the alpha particles. It was small, which we later on called the nucleus. Nuclear fusion is a reaction that takes place in stars. Which show describes this reaction? An atomic nucleus splits. No, it does not split. Two atomic nuclei join, and the energy is released. Yes, energy is released. What is the half-life of this source? So it started off with 38,000 counts. Can I find the half-life? When you divide 38,000 by 2. 38,000 by 2. This is 19,000, right? It's 19,000. Where is 19,000? It's somewhere in between. Okay, 26,000, 17,000. Therefore, the time would be between 1 and 2 years. It's more than 1 year, but less than 2 years.